All right, so hope everybody's doing okay. Today I'd like to talk to you a little bit about exponential equations. This is just building off of one of the tasks that I had you do last week, was to be able to write something using kind of like a common base and to simplify an exponential expression. So we're going to apply that in certain types of exponential equations. So consider the exponential equation that I have written here. And what we're going to try and do with this in order to solve for the exponent is to write both sides of this equation using a common base. So in other words, like 16 could be written as either 4 squared or as 2 to the 4th power. And then 8 could be written, unfortunately, not as 4 to a power directly, but we could write it as 2 to a power. So over here, I'm going to write both sides using that same base of 2, and I'm going to write this as 2 to the 4th raised to the x minus 1 power equals 2 to the 3rd. Of course, over here on the left-hand side, we can multiply these two exponents. That's just a power property for exponents. So this is going to be 2 to the 4x minus 4 equals 2 to the 3rd. Now, in order for these two sides of the equation to be equal to each other, all we have to do is set the exponents equal, right? Because if this has the same exponent, that has the same exponent, then it's going to be 2 to the same power on both sides, and they will be equal. So the question then becomes, when does 4x minus 4 equal 3? And that's not too hard to solve. 4x equals 7. Just add 4 to both sides and divide. And we've got 7/4. All right? And there we go. That's the solution to our exponential equation. So let's try another one. I'm going to scroll down here. This one's a little bit harder. Again, we're going to try and make a common base between the left-hand side of the equation and the right-hand side of the equation. And as you can probably guess, the base that we're going to use is 3. So on the left-hand side of the equation, this is going to be 3 to the negative 3rd power raised to the 2x minus 1. And on the right-hand side of the equation, we have 9, which is 3 squared, times 3 to the 1/2 power, right? We're going to simplify. We've got to simplify both sides of these equations, simplify these exponents here. On the left-hand side, we will multiply. That's 3 to the negative 6x plus 3. Make sure you distribute the negative with it. That didn't show up too well. Make that 3 equals 3 to the 2.5, which we can combine to say 5/2. All right. Now, just like before, in order for these two sides to be equal to each other, all we need is the exponents to be equal. So that means negative 6x plus 3 has to be equal to 5/2. Now, if we want to apply our rational equation practice and get rid of this denominator of 2 just to make it easier, we can double both sides and get negative 12x plus 6 is equal to 5. Subtract, you get negative 1. Divide, you're going to get x to the 1/12 power. Okay, and so that's it. That's how we solve these type 1 equations when you have an exponent that has a variable in it. The variable is in the exponent, and we can create a common base between these two sides of the equation. That's what we're going to do. Create a common base, set the exponents equal to each other, and solve. Thank you.